Hello friends, today's question: a mass m supported by a massless string wound around a uniform hollow cylinder of mass m and radius r. If the string does not slip on the cylinder, with what acceleration will the mass fall on release? So this is our uniform hollow cylinder of mass m and radius r, and this is a mass m supported by this massless string. In this case, let us suppose T is the tension in the string and mass m is falling in the downward direction with the acceleration of a, and we are going to have mg in the downward direction and tension will be the force acting in the upward direction, and we say that the angular acceleration of this cylinder is, let us suppose, is given as alpha. So in this case, if tau is the torque acting on the cylinder, so we can say that tau is the torque acting on the cylinder. Therefore, we can say or write the equation that tau will be equal to the force, that is tension T, and the radius of the cylinder. Let us call this equation number 1. And we said that alpha is the angular acceleration. So for alpha as the angular acceleration and I as moment of inertia, so we can write the equation as tau will be equal to moment of inertia multiplied by angular acceleration. Let us call this equation number 1. So from equation 1 and 2, from equation 1 and 2, we can write that our tau into r will be equal to moment of inertia into angular acceleration. Let this be equation number 3. And we know that the mass is falling downward with the acceleration of a, or indirectly we can say that a is the linear acceleration of the cylinder. You can say for linear acceleration a for the cylinder, we can write the relationship that our linear acceleration a will be equal to angular acceleration multiplied by the radius, or we can say our angular acceleration is equal to a upon r. And the moment of inertia for the hollow cylinder, that is I, moment of inertia for hollow cylinder, that is I, is equal to mass into its radius square. Therefore, we can substitute value of angular acceleration as well as moment of inertia in equation 3. You can write from equation 3, we get T into r is equal to moment of inertia is given as mr square, and we have angular acceleration is as a upon r. Here r goes with this r and r cancels, so therefore tension is equal to mass into acceleration. Now if we write the equation for the motion for the mass m, which is moving in downward direction. Equation of motion for mass m, which is like this. So, this is our mass m moving downward with the acceleration of a, and we have tension T. Downward we are going to have mg. So, equation of motion will be equal to mg minus T will be equal to ma, and we already proved that tension T is equal to ma. So, substituting here, you can say, but T is equal to mass into acceleration, we just proved. So, therefore, we can write mg minus ma is equal to ma. So, mass cancels out. So, this is our mg minus ma is equal to ma. Mass cancels out. So, we get g is equal to 2a, or a is equal to g by 2. So, we are supposed to find out the acceleration with which the mass falls. So, we can say this is the acceleration with which mass m falls, and if we check the option that is available with us, we can say that option number B is the correct option. Option B is correct. So, this completes the question. Thank you.